This is section 2.5a, the chain rule. By the end of this video, you should be able to use the chain rule to evaluate more complex derivatives. So let's get started. Suppose we were asked to differentiate the following function. F of x is equal to the square root of x squared plus 1. The differentiation formulas that we've already learned, so the power rule, the product rule, and the quotient rule, actually don't allow us to differentiate this function. You should notice, though, that f is a composite function. In fact, if we let y equal f of u, which equals the square root of u, and u equal g of x, which is equal to x squared plus 1, then we can write y equals capital F of x, which is equal to f of g of x. That is, capital F is f composed with g. We know how to differentiate both smaller functions, so it would be useful to have a rule that would tell us how to find the derivatives of capital F is equal to f composed of g. It turns out that the derivative of the composite function is actually just the product of the derivatives of f and g. This fact is one of the most important differentiation rules we have, and it's actually called the chain rule. So if g is differentiable at x and f is differentiable at g of x, then the composite function f equals the composition of f and g, defined by capital F of x is equal to f of g of x, is differentiable at x, and f prime is given by the product capital F prime is equal to f prime of g of x times g prime of x. Essentially, what this really boils down to is that the chain rule says, in words, that you take the derivative of the outside function and you multiply it by the derivative of the inside function. So multiply by the derivative of the inside function. So let's actually go back and let's try to differentiate that function that we just started with, that example. So let's find f prime of x if f of x is equal to the square root of x squared plus 1. So we are going to use the chain rule in this instance. So the chain rule, let me spell chain right. The chain rule basically says that if we take the two functions and we call the inside g of x and the outside function f of x, that the derivative of this function f prime of x is going to be equal to f prime of g of x times g prime of x. So essentially what we're going to do is we're going to hold the x squared plus 1 on the inside when we do the differentiation of the first part. We're going to just hold it as itself. We're not going to do anything with it, and we're just going to differentiate the outside as if it was just the square root of x. Because we already know that the derivative with respect to x of the square root of x is going to be 1 over 2 square root of x. And so what we do is that we take the derivative of the outside function, which is this square root function, and so it'll be 1 over 2 times the square root of whatever's on the inside, which is x squared plus 1. And then we'll multiply it times the derivative of the inside function, which is x squared plus 1, and the derivative of x squared plus 1 is just 2x. And so our final derivative of f prime is going to equal 2x over 2 rad x squared plus 1, which we can actually simplify by canceling out the 2's, and we get that it's equal to x over the square root of x squared plus 1. So again, we hold the inside piece essentially constant, or we treat it as one variable, and we differentiate the outside function first, and then we multiply it by the derivative of the inside piece, the piece that we held as a single variable. Let's try it again. Okay, this one's going to be a little bit more complicated. It's going to involve some trigonometry, but the process is still the same. So we're going to differentiate y is equal to the sine of x squared, and we're also going to differentiate y is equal to sine squared x, and we're actually going to show that they're going to give you two different derivatives. So let's start with a, the derivative of sine x squared. So for a, and let me change my color here. The derivative of y equals sine x squared. So if y equals sine x squared, the chain rule says that we're going to take the derivative of the outside function first. So just the derivative of the sine function, which we already know and we've learned in the past couple of days that the derivative of a sine is cosine. So y prime would be the cosine of, we keep this whole piece by itself and we don't touch it. So it'll be the cosine of x squared times the derivative of the inside function, which is just 2x. And so my derivative of y equals sine x squared is going to be the cosine x squared times 2x, or we generally like to clean it up a little bit and put the trig functions last. So this is really just 2x cosine x squared. This is very different than if we take the derivative of sine squared x. So if y equals sine squared x, which we can actually rewrite to be a little bit easier to read as sine of x, the whole quantity squared, we're going to take the derivative of the outside function, and in this case the derivative of the outside function is going to be this squaring function. It's just like we're taking the derivative of x squared. And so y prime would be, well, we take the derivative of the outside function, which would be 2, and we'd use the power rule, so we'd slide the 2 in front and we'd subtract 1, times this, which will keep constant and we won't touch it. So it'll be 2 times sine x, and then it'll be times the derivative of the inside function, which is going to be the derivative of sine again. It's going to be cosine x. So y prime is going to be 2 sine x cosine x. So again, the chain rule works by taking the derivative of the outside function and holding the inside function constant, and then you take the derivative of the outside and you multiply it times the derivative of the inside. Let's try it again. This box just tells us that we can combine it with the power rule, but we already did that in the last example when we were dealing with the sine of x squared. But we can do it with this specific example. So if we were to differentiate y equals x cubed minus 1, the whole thing raised to the 100th power, the way that the chain rule works is that y prime would be the derivative of the outside function, which we're going to use the power rule, so we'll slide the 100 in front, times this function, whatever it is, and since we're using the power rule, we'll multiply it we'll subtract 1 off the exponent, and then we just multiply the function by the derivative of the inside. So the derivative of x cubed minus 1 is going to be 3x. And so we can clean this all up, and you get that y prime is 300x times x cubed minus 1 to the 99th power. We can also start to fold in some of the other rules that we've learned. Especially with in regards to the power rule, we've already tackled questions like this where we have a radical in the denominator, and what we did with those questions is that we turned the radical into an exponent and then we pulled it out of the denominator by making it negative. So first off, we're going to take f of x that's equal to 1 over the cube root of x squared plus x plus 1, and we're going to rewrite it as x squared plus x plus 1, and the cube root is going to be to the 1/3 power, so we're going to pull it out of the denominator and we're going to make it negative. So it's to the negative 1/3 power. Okay, and then if we were to try to differentiate this, then we would use the chain rule. So the chain rule says that we're going to take the derivative of the outside function, so the derivative of this quantity to the negative 1/3 power, and we'll use the power rule. So we're going to slide the negative 1/3 in front, and keep the function the same on the inside, x squared plus x plus 1. And then we're going to subtract 1 from negative 1/3. So we're going to subtract 3/3 from 1/3, and so we'll get negative 4/3. And then we take this and we multiply it by the derivative of the inside function. So we'll take the derivative of x squared plus x plus 1, which is going to be times 2x plus 1. Well, this is not exactly the way I want it to look yet, so we're going to have to clean it up. The first thing that we need to do is that we need to take care of the negative exponent. So we're going to take that and we're going to put it back in the denominator of the function. So we'll get negative 1 over, and the 4/3 root is going to be the cube root of this whole function to the 4th power. So x squared plus x plus 1 to the 4th power times 2x plus 1. And this is actually not exactly where we want it to be yet either, so we're going to take the 2x plus 1 and we're going to multiply it into the top of the fraction. So f prime of x is actually going to be equal to negative 2, and we're going to distribute our negative 1. So negative 2x minus 1 over the cube root of x squared plus x plus 1 to the 4th. In summing up, the chain rule is actually very simple. You just have to remember that you're always taking the derivative of the outside function and you're multiplying it times the derivative of the inside function. That's pretty much it in a nutshell. What I want you to do is I want you to take the worksheet that I've made for you and I want you to practice it. And we'll start diving into some harder problems on Monday when I get back.